This is number 73, implicit parabola. The parabola shown in the graph is defined implicitly by this equation. A, find the coordinates of point A where the tangent line is vertical. And then we'll find the coordinates of point B where the tangent line is horizontal. So they're saying we have a vertical tangent line at A and a horizontal tangent line at B. So let's find the derivative. We have 2x minus first times the derivative of the second plus the second times the derivative of the first, and then plus 2y dy dx minus 4 is equal to 8. No, not equal to 8, equal to 0. We got to take the derivative of everything, and the derivative of 8 is 0. Let's factor out a dy dx. We have dy dx times 2y minus 2x. Now remember, this is going to be a minus 2y. So let's add 4 over. We'll subtract the 2x, and then this will be minus, so we'll have to add this over. Now this is equal to 2y, because remember it'd be minus, plus 4 minus 2x. And then we'll divide by 2y minus 2x. So dy dx, the derivative, is y plus 2 minus x. Everything has a 2, divided by y minus x. Well, in order to have a vertical tangent line, the derivative has to have 0 in the bottom. So we want to know where y minus x, this is part A, where y minus x is equal to 0, or where y equals x. Well, now, this point right here is on this line, and the point is on this curve. So that's a system of equations. Let's plug x in for y. We have x squared. Now I'm plugging x in for y for that one and that one right there. X squared minus 2x squared plus x squared minus 4x is equal to 8. And let's see, x squared minus 2x squared. Those are two positive x squareds and two negative x squareds. So x is equal to negative 2. Now we plug negative 2 back in somewhere, but this says that y equals x. So we have the point negative 2, negative 2. Letter B, now we want find the coordinates of point B where the tangent line is horizontal. So to have a horizontal tangent, it has to have a slope of 0. So now we need to make the top 0. So y plus 2 minus x is equal to 0. So y is equal to x minus 2, and now we have a system of equations. So we'll plug x minus 2 in for these two y's right here. Now it's going to be a little bit more algebra. X squared minus 2x times x minus 2 plus x minus 2 squared minus 4x is equal to 8. So let's multiply all that out. X squared minus 2x squared plus 4x plus x squared minus 4x plus 4. Whoops, I don't know why. I saw those parentheses and just wrote parentheses. Don't need them anymore. Plus 4 minus 4x equals 8, because we're plugging this in. So we have 2 positive and 2 negative x squareds, 4x minus 4x. Subtract the 4 over, negative 4x equals negative 4. No, just positive 4. And so x is equal to negative 1. So we have negative 1 comma. Let's plug negative 1 in here, and we have negative 1, negative 3. Find the first derivative. So y prime is equal to 2 secant of the third root of x. And then the derivative of secant is secant tangent, so secant third root of x, tangent of third root of x, and then we need to multiply times the derivative of x to the 1/3, which is 1/3 x to the negative 2/3. All that's in the bottom, so the 3 is in the bottom, and then the third root of x squared is also in the denominator, because it's a negative power. Y prime here is 1 over x to the third, because the derivative of natural log is 1 over x, or 1 over what we're taking the natural log of, and then times 3x squared. So that's equal to 3 over x. Inverse cosine y prime is equal to, let's start with negative 1 over square root of 1 minus 4x squared, because that's actually 1 minus x squared, but it's 1 minus this thing squared, but then times 2. Not much we can do here, just put negative 2 over square root of 1 minus 4x squared. Y prime here is 2 sine of x squared plus x, then times cosine of x squared plus x, because the derivative of sine is cosine, and then times 2x plus 1. On this row, find the second derivative. So first derivative is e to the x to the third, because the derivative of e to the x is e to the x, so we just write that again. But then times the derivative of the inside is 3x squared. Now when we take the second derivative, we have to use the product rule. So first times the derivative of the second, but this is the derivative of e to the x to the third. So we have times 3x squared e to the x to the third, and plus second times derivative of the first, ex to the third. And we could take out a 3x and an e to the x to the third. So that leaves a 3x to the third. 3x to the third plus 2. Find the third derivative. First derivative is 3 times 2x minus 4 squared, but then times the derivative of the inside is 2, and that's 6 times 2x minus 4 squared. Second derivative is 12 times 2x minus 4 to the first, but then times 2. That's 24 times 2x minus 4. And then the third derivative is 24, but then times 2, which is 48. All right, on this one, let's take the first derivative. 2x plus 2y dy dx is equal to 0. So we're going to minus 2x. So negative 2x, and then divide by 2y. Now the 2's are going to cancel, so it's just negative x over y. Need a little bit more room here for second derivative. There we go. So second derivative is bottom times derivative of the top minus the top times the derivative of the bottom, which is 1, but it's the derivative of y, so we need dy dx, over y squared. Now that's negative y plus x times negative x over y, because we know what dy dx is, over y squared. Now we need to multiply everything times y to get rid of this denominator. So everything times y. That's negative y squared minus x squared over y to the third. But if we take a negative out of the top here, we get negative y squared plus x squared. Well, if we look way back up to the top, it says that that is equal to 20, that x squared plus y squared is 20. So negative 20 over y to the third is the final answer. Where are the slopes of the tangent lines vertical and horizontal? So let's take the derivative. First times the derivative of the second. So the derivative of e to the negative x is e to the negative x, but you got that negative there. Plus the second times the derivative of the first. Well, we can factor out, let's see, a 3x and a negative and an e to the negative x. Do I want to? Yeah, I want to factor out a negative because that's negative. So x minus 2. Now that's negative 3x times x minus 2 over e to the x, because I can bring this down to the bottom and make the power positive. So the first one asks for vertical. Vertical, none. You cannot make the denominator 0. If you have e to the x equals 0, that means, what do you raise e to the x to get 0? E to the 0? No, that's 1. E to the negative 1? That's 1 over e. That's still positive even. So you can't take e to the x and get 0, so none. Horizontal? Horizontal, that's where the top is going to be 0. So at x equals 0 and x equals 2.